The signal was in the database the way old furniture was in a house, present so long that nobody saw it anymore. It had been logged in the 63rd year of the expanded survey, filed under catalog number ESC7441B, flagged with the standard notation that meant assessed, explained, move on. The explanation on file was pulsar variant, which was the notation that meant natural rotating neutron star producing regular radio emissions, interesting to specialists, not relevant to the search for anything else. 14 research teams across 60 years had looked at ESC7441B and written pulsar variant and moved on. Dr. Yale Morin looked at it on a Tuesday in March and did not move on. She was 44 years old and she was not, by the standards of her field, a prominent researcher. She had published 23 papers across a 17-year career, which was a respectable number and not a remarkable one. She worked at the Rennes Landing Radio Observatory, which was a mid-tier facility with good equipment and a small staff, and a funding situation that was, as it had always been, uncertain. She had come to radio astronomy because she had, since the age of 9, believed that the universe was saying something, and that the problem was not the universe's willingness to speak, but humanity's willingness to listen. And she had spent 17 years developing increasingly precise tools for listening. She had not found anything yet that could not be explained. ESC7441B came to her attention not through her own research, but through a graduate student named Cale Bren, who was 26 years old, and who had the specific quality of a young researcher who had not yet learned what was not worth pursuing. He had been doing a survey of long-duration catalog signals for his dissertation, and he had come to Yale's office on a Tuesday morning with his tablet and the expression of someone who had found something they were not sure was real. He said, "I want to show you something." She said, "Show me." He pulled up the ESC7441B catalog entry. He said, "This has been in the database for 60 years. He said, "It's filed as pulsar variant." She said, "I know the catalog. What about it?" He said, "I don't think it's a pulsar." She looked at him. She said, 14 teams have assessed it." He said, "I know." He pulled up the signal data, not the summary assessment, the raw data, the actual recorded signal across 60 years of intermittent observation. He said, "Look at the interval pattern." She looked. Pulsars produced regular intervals, the specific, clock-like regularity of a rotating neutron star, precise in the way that physics was precise, varying only within the narrow parameters that stellar mechanics allowed. ESC7441B's intervals were regular, but they were regular in a pattern that was not the pattern of a rotating body. They were regular in the pattern of something that had been designed to be regular, a pattern that was almost pulsar-like, and was, on close examination, not quite, in the specific way that almost was more interesting than either yes or no. She said, "How long did it take you to see this?" He said, 3 weeks. "I almost didn't. It's very close to pulsar variance." She said, "Close but not within." He said, "Outside the boundary by a margin that's small enough that 14 teams didn't flag it." He paused, or flagged it and decided it was instrument variance. She said, "Is it instrument variance?" He said, "I checked across 6 different observation arrays spanning 40 years of equipment generations. The margin is consistent across all of them." He paused. "It's not the instruments." She looked at the data for a long time. She looked at it the way she had looked at data her entire career, with the specific quality of attention she had developed since the age of 9, the attention of someone who believed the universe was saying something and who was willing to be patient about hearing it. She said, "Nobody has listened to it." He said, "It's been observed 14 times." She said, "Observed." She paused. "I mean listened. Has anyone converted the signal to audio and listened to it?" He checked the assessment records. The 14 assessments had all been conducted on the visual data, the waveform analysis, the interval calculation, the frequency assessment. None of them had rendered the signal as audio. He said, "No." She said, "That's where we start." The observatory's director was a man named Hal Quelindra, who had been running the facility for 18 years, and who had, across those 18 years, developed a comprehensive understanding of which of his researchers were pursuing something real, and which were pursuing something they needed to pursue for reasons that were more personal than scientific. He had learned that both categories were worth funding when the budget allowed, and that distinguishing between them was less important than it appeared. because occasionally the personal reasons led somewhere the scientific reasons had missed. He listened to Yale's funding request for 6 months of dedicated observation time on the secondary array and a small research grant for signal analysis work, and he said, 14 teams, Yale. She said 14 teams looked at the data. Nobody listened to it. He said, that's a distinction without a difference. She said, I don't think it is. She paused. I think when you convert a signal to its audio representation, you are engaging a different analytical capacity than visual waveform analysis. She paused. I think human pattern recognition in audio is more sensitive to certain kinds of structure than visual analysis. She paused. I think that is why music exists and why mathematics doesn't fully explain why it works on us. He looked at her. He said, that is not a rigorous scientific argument. She said, I know. She paused. Give me 6 months and I'll give you a rigorous one, or I'll tell you were right. He gave her 6 months. He gave her the secondary array and the small grant and a graduate student, which was Cale, who had found the thing and who deserved to be present when they found out what the thing was or wasn't. He said as she was leaving his office, Yale, 14 teams. She said, I know Hal. She said it without defensiveness, with the specific quality of someone who had heard the objection and understood it and had decided to go anyway. She said, that's kind of the point. The first month was the conversion. Taking 60 years of intermittent radio signal observations and converting them into a coherent audio representation was not a simple process. The signal had been observed at different times by different arrays with different instruments and different recording standards, and integrating 60 years of heterogeneous data into something that could be rendered as continuous audio required the kind of painstaking technical work that graduate students were, Cale discovered, exactly the right people for. He spent 30 days on the integration. He came to Yale at the end of month 1 with a file that was 4 hours and 17 minutes long, the complete integrated audio rendering of 60 years of ESC 7441B observations. She said, have you listened to it? He said, I started to. He paused. I stopped. She said, why? He said, I wanted to listen to it with you. They sat in the observatory's small audio analysis room on a Thursday evening with the lights low and the speakers calibrated, and 4 hours and 17 minutes of signal rendering queued on the system, and Yale pressed play, and they listened. For the first 40 minutes it sounded like noise. Not random noise, structured noise, the specific textured quality of something that had internal organization but whose organization was not yet apparent. It sounded the way a piece of music sounded when you were hearing it in a language you didn't speak. There was clearly something there, clearly pattern and intention, and the pattern was not accessible. At minute 43, Yale said, stop. Cale stopped the playback. She said, go back 30 seconds. He went back 30 seconds and played it again. At the specific point she was listening for, a moment in the signal that lasted approximately 4 seconds, there was a pattern that her auditory system had caught before her conscious mind had processed it. A rhythm within the noise. Not a simple rhythm, a complex one, layered, the kind of rhythm that appeared in certain kinds of human music and that the human auditory system was specifically calibrated to detect. She said, there. He said, I hear it. She said, that is not a pulsar. He said, no. She said, play the next hour without stopping. He played the next hour. The rhythm appeared 7 more times, not at regular intervals, at intervals that were themselves a pattern within a pattern, the specific nested structure of something that had been designed to reveal itself gradually to a listener who was paying attention. At the end of the hour, she said, it's teaching us to hear it. He looked at her. She said, the structure is graduated. The first 40 minutes establish the noise floor. The rhythmic pattern appears when a listener has calibrated to the noise, when they've been listening long enough that their auditory system has normalized the background and can hear what's in it. She paused. If you only listen to a short sample, you hear noise. You have to listen long enough. She paused. You have to be patient. He said, the 14 assessment teams. She said, none of them listened for 40 minutes. They took samples. Standard assessment protocol is 5 to 10-minute samples at multiple frequencies. She paused. The signal is designed so that 5 to 10-minute samples sound like noise. He said, designed. She said, that is the word I used. He said, Yale. She said, I know. She paused. Keep listening. Month 2 brought the structure analysis. With the audio rendering as the primary analytical tool rather than the visual waveform, the signal's organization became progressively more apparent. Yale and Kale spent month 2 doing what Yale called close listening, the specific, patient, repeated engagement with the audio that produced, gradually, a map of the signal's internal architecture. The architecture was complex. It had layers, a bass rhythm that was consistent across all 60 years of observations, a secondary pattern that varied within parameters, and a tertiary structure that they did not fully identify until week 7 of month 2, and that Kale found at 2 in the morning and called Yale about immediately. She answered on the second ring. He said, I found a third layer. She said, I'll be there in 20 minutes. She was there in 15. The third layer was not rhythm. It was not pattern in the way the first 2 layers were pattern. It was variation, specific, structured variation in the signal's frequency that occurred at precise points in the secondary pattern cycle. The variation was small enough that it had been within the noise threshold for all 14 previous assessments. The variation was, Kale had determined by 2 in the morning on a Wednesday, not noise. He showed her the analysis. He said, the frequency variations are quantized. They occur at discrete values, not continuously. He pulled up the distribution. He said, there are 47 distinct frequency values that the variations take, exactly 47, not approximately, exactly. She looked at the distribution for a long time. She said, 47 is a prime number. He said, yes. She said, the variations occur at prime number-based intervals within the secondary cycle. He said, yes. She said, and the 47 distinct values. He said, are themselves arranged in a sequence that I cannot yet characterize, but that has internal mathematical structure that I can demonstrate, is non-random to a confidence level of, he paused, to a confidence level that I am slightly afraid to say out loud. She said, say it. He said, 10 to the negative 31st. The probability that this structure is naturally occurring is 10 to the negative 31st. The room was quiet for a moment. She said, write everything up, all of it. Every step of the analysis, every methodological decision, every confidence interval. Write it as though you are writing for a reviewer who is actively looking for errors. He said, that will take 2 weeks. She said, take 2 weeks. She paused. We are going to need this to be bulletproof. He said, Yale, what do you think it is? She looked at the frequency distribution on the screen. 47 discrete values arranged in a mathematical sequence that had a 1 in 10 to the 31st chance of occurring naturally. She said, I think it's the same thing I've thought it was since you showed me the interval pattern on a Tuesday morning. She paused. I think it's a message. I think someone built something to transmit it, and I think the transmission has been running for at least 60 years, and probably much longer, and I think the message is encoded in 47 frequency values arranged in a sequence we haven't decoded yet. She paused. She said, I think someone has been trying to talk to us for 60 years, and we've been walking past it every day and calling it a pulsar. Month 3 brought the decoding attempt and the first outside contact. Yale made 2 decisions at the beginning of month 3 that she later understood as the 2 most consequential decisions of the project. The first decision was to attempt decoding alone, to keep the research within the observatory team until the analysis was complete enough to withstand external scrutiny. She had seen, across 17 years in the field, what happened to anomalous findings when they were released before they were bulletproof. They were not examined. They were dismantled, correctly or not, by reviewers who had decided before reading that they were wrong. She wanted to be bulletproof before she was visible. The second decision was to contact Dr. Vernoor. Vernoor was a mathematician at the Institute for Advanced Computation who had spent 20 years working on non-human mathematical structures, the specific theoretical field that asked what mathematics would look like if it had been developed by a mind that was not human, and whether human mathematics was equipped to recognize non-human mathematical reasoning when it encountered it. He was the only person she could think of who had the specific qualifications the third layer required. She sent him the frequency distribution and the mathematical structure analysis with a message that said, I need you to look at this without context first. Tell me what you see. I will give you context after. He responded in 4 hours. He said, where did you get this? She said, tell me what you see first. He said, I see a base 7 counting system embedded in a sequence that uses prime factorization as an organizational principle in a way I have not seen in any human mathematical tradition. He paused in the message. He said, I see a mathematical structure that was not built by a human mathematician. She gave him the context. He was at the observatory in 3 days. He was 51 years old, and he had the quality of someone who had spent 20 years preparing for exactly this, and who was, now that it was here, very calm in the way that people were calm when something enormous arrived, and the only useful response was precision. He sat in the audio analysis room and listened to 4 hours and 17 minutes of the signal. He did not speak during the listening. Afterward he said, play me the third layer isolated. Kale had developed a filter that could isolate the frequency variations from the base signal. He played the third layer isolated. Ver listened for 40 minutes. Then he said, it's counting. Yale said, what? He said, the sequence. It's a counting sequence in base 7. The 47 frequency values are not 47 arbitrary values. They are the first 47 elements of a base 7 counting system expressed as frequency ratios. He pulled up his tablet and showed them the mapping. He said, once you see it as base 7, it resolves. The internal structure is, he paused. It's extremely clear. It's counting, and then it is doing arithmetic with what it has counted. And then it is doing something with the arithmetic that I need more time to characterize, but that I believe is the next layer of the message. Yale said there's a next layer. He said there are probably many layers. This is the introduction. He paused. This is whoever sent this saying, here is how we count, here is our mathematics, here is the foundation. He paused. The rest of the message is built on this foundation, and we will not be able to read the rest until we fully understand this part. He said it with the specific quality of a man, describing a long road. He was happy to walk. Kale said, how long? Ver said, to fully decode the mathematical foundation. Months. To begin reading what comes after it, I don't know. He paused. As long as it takes. Yale said, the signal is still transmitting. He said, yes. She said, 60 years of transmission, and we haven't responded. He was quiet for a moment. He said, do you want to respond? She said, I want to finish decoding first. I want to understand as much as we can understand before we answer. She paused, but yes, eventually, I think that's the point. She paused. I think whoever sent this built it specifically so that the act of decoding it would give us enough shared mathematical language to respond. The base 7 system, the prime structure, these are things we can recognize and work with. They are not arbitrary. They are the specific mathematical concepts, most likely to be universal between any two civilizations, that have developed mathematics independently. She said, they thought about how to talk to us before they knew we existed. Ver said, yes, that is exactly what they did. Month 4 brought Hal Quelindra back into the room. Yale had been filing brief monthly updates with the observatory director, technically accurate, carefully written to be complete without being alarming. She had described the signal analysis as ongoing and promising. She had not described base 7 counting systems or mathematical structures built by non-human minds. In month 4, Hal came to the audio analysis room unannounced on a Tuesday morning and stood in the doorway looking at the 3 of them, Yale, Kale, and Ver, who had been at the observatory for 6 weeks by that point, and at the screens covered in mathematical notation and audio waveforms and the specific organized density of 3 people who had been working on something large. He said, update. Yale said, sit down, Hal. She told him everything. She told him in the specific order she had assembled it, the interval pattern, the audio rendering, the rhythmic structure, the 47 frequency values, Ver's base 7 identification, the mathematical foundation, what they believed the signal was and who they believed had sent it. He was quiet for a long time after she finished. He said 60 years. She said, at minimum. The signal may have been transmitting longer and only entered our detection range 60 years ago, or it may have been transmitting for 60 years specifically. We don't know yet. He said, and you want to respond. She said, eventually, when we have enough of the mathematical language to say something coherent. She paused. We can't respond yet. We don't have enough of their language. She paused. But yes, that is where this goes. He said, Yale, do you understand what you are telling me? She said, yes. He said, I need to report this upward. This is beyond observatory level. He stopped. He said, this is the largest finding in the history of this field if you are right. She said, I know. He said, and if you're wrong. She said, then the analysis is wrong and we find the error and we report that too. She paused. I'm not wrong, Hal. She said it without drama. She said, but check everything. Send it to reviewers. Do everything the process requires. She paused. The signal will still be there. It has been there for 60 years. It will be there while we do this correctly. He said, who else knows? She said, the three of us. He said, it stays that way until I say otherwise. She said, agreed. He stood up. He looked at the screens for a moment. The waveforms, the mathematical notation, the audio analysis equipment. The file that was 4 hours and 17 minutes long and that contained, somewhere in its layered structure, a message from somewhere that had been waiting 60 years for someone to listen. He said, Tuesday. She said, Tuesday. He said, you told me on a Tuesday morning that 14 teams were wrong. He paused. I almost didn't give you the 6 months. She said, I know. He said, I'm glad I did. He left. Yale turned back to the screens. Ver was already working, his tablet covered in base 7 notation, the next layer of the mathematical sequence partially mapped. Cale was at the audio system, running a new filter pass on the 3rd layer to see if the isolation could be refined. She sat down. She looked at the signal waveform on the primary screen, 60 years of transmission, patient and continuous, transmitting its base 7 mathematics into a universe that had been walking past it, and calling it a pulsar. She thought about the age of the signal. She thought about whoever had built the transmitter, wherever they were, however long ago, whatever they had understood about the universe and about the likelihood of someone eventually paying attention. She thought about the design of the signal, the 40-minute patience requirement, the graduated revelation, the mathematical foundation chosen for universality. She thought they knew it might take a long time. She thought they built it to wait. She thought 60 years is nothing to something built to wait. She thought about 9-year-old Yale, who had believed the universe was saying something, and had spent 35 years developing the tools to hear it, and had almost not looked at a catalog entry filed as pulsar variant and moved on. She thought patience goes both ways. She thought they were patient enough to keep transmitting. She thought I was patient enough to listen. She thought that is how this works. That is how it was always going to work. Not instruments or funding or institutional support. Those things mattered, but they were not the thing. The thing was a graduate student who had not yet learned what was not worth pursuing, and a Tuesday morning, and a question so simple it had not been asked in 60 years. She thought, has anyone listened to it? She opened the audio file. She put on the headphones. She pressed play. She listened. Outside the observatory, the night was dense with stars. The Milky Way overhead in the specific clarity of a dark sky sight. The secondary array dish pointing at a patch of sky that looked like every other patch of sky, and that contained, in the radio frequencies that human ears could not hear, but that human instruments could render into sound, a signal that had been transmitting since before Yale was born, from somewhere in the direction of a star system that Ver was already calculating. Patient and precise, and built to last until someone listened. Someone was listening. The signal kept transmitting. It had been waiting for this.